Today we have a Noco GB40 that a customer sent in for repair. The customer said he's unable to jumpstart his car battery using the device. We're going to have a look at it. First, we'll verify the issue. Let's try powering on the Noco. It appears to be fully charged. Let's try the torchlight. Torchlight seems to be working. Next, I'm going to test to see if the battery is taking charge. Let's plug in the Noco. Okay, and it appears to be taking just over 1 amp of current, so the battery does seem to be charging, or the batteries rather. Let's see if we can get a zoom in on the meter so you can see. The battery is taking a charge. It's a bit fuzzy, but I think that's the best I can do for now. You can see here it's just about 1.17 amps that's being drawn from the Noco device. Okay, next we're going to test the boost circuit. Let's unplug the charger, take the torch light off, turn the Noco on again. Still seems to be fully charged. Let's test the boost circuit. Okay, see the flashing LEDs. The Noco does seem to be boosting. However, for confirmation, we do need to check the voltage at the end of the clamps. So let's do that. Red probe on red clamp and black probe on black clamp. And it seems we're only getting 0.6 of a volt across the clamps, which is definitely not going to jumpstart any vehicle. So it seems even though we've got the flashing LEDs, the Noco boost circuit isn't working. Another thing you may have noticed is when we turned the boost circuit on, let's turn it off and turn it on again. There wasn't a clicking song. The clicking song usually indicates the relay being activated, which is a significant part of the Noco's boost circuit. Let's try again. So we see once again flashing LEDs, but it doesn't appear as though the relay was activated because we did not hear the clicking song. Once again, we'll test the voltage across the clamps. And we've still got 0.6 of a volt. So let's open this Noco up and see what's happening. I'm going to be doing the routine test. However, my focus at this time is perhaps going to be on the relay and why it isn't activated, or at least why we don't hear it being activated. Okay, after disassembling the Noco, I was unable to find any faulty components on the circuit board, and the battery also appears to be testing okay. We have the battery negative just here, and this red cable is the battery positive. So if we check the voltage directly across the battery, see we have just over 12 volts, so that's absolutely fine. However, when I tested the relay, which was installed here on a separate circuit board directly attached to the battery, I found that the relay was indeed faulty. So I took it out of circuit to test again to ensure the relay was actually the issue. And the relay also tested faulty out of circuit. The part number on this relay is HFV7-P. Let's see if we get a close-up on that. It's rated for 70 amps, 14 volts. Now it's a 4-pin relay, and as you can see, pins 85 and 86, well, hopefully you can see, pins 85 and 86 are connected. They are the control side of the relay. Pins 87 and 30 are the load side of the relay, which is open by default. The way how this works is, when there's a charge or the load side, that's pin 85 and 86, is energized, it creates a force that causes the switch across the load side to close, hence completing the circuit. And it's this closing of that switch that makes that clicking sound that we hear. So usually if you don't hear the clicking sound, it may be an indication that the circuit isn't being completed. Now this may happen for a number of reasons. One may be that the switch inside of the relay, that's pins 85 and 86, isn't being energized, or it may be that the internal wiring of the relay is faulty. Let's do some more tests. So below the relay, we can actually see how the pins are numbered. Hopefully you can. If you can't, let me call it out so you can see. Spin it over. At the top, we have pin 87. Below, we have pin 30. So those two pins form the load side. And over here, we have pin 85 to the left, and to the right we have pins 86. So if you remember from the diagram, pins 85 and 86 are connected, so we should find continuity across those two pins if we were to test them with our multimeter. However, pins 30 and pins 87 by default are open until the load side, pins 85 and 86, are energized. So let's test that. Put our meter in continuity mode, and we're now going to test across pins 85 and 86, which is the control side of the relay. We should get continuity, and hear a beep. So we see there is no continuity across the switch side of the relay, that's pins 85 and 86. According to the diagram, if you remember, pins 85 and 86 should be connected at all times. So we should have found continuity. Let's just check over pins 30 and 87, the load side. There isn't any continuity, but there shouldn't be anyway unless the circuit has been activated. Now, that's perhaps enough to verify that this relay is faulty. However, let's just pass some power through it, because we can. Now the way we would know which way to apply power to this relay is by looking at how it was installed on the circuit board. bit too much zoom. Let's get out. Okay, so at the top here we can see there are 3 pins, hopefully you can, 3 pins that are arranged horizontally, and at the bottom there are 3 more pins that are arranged vertically. So if we look at our relay, zoom out, we can see it was installed like this, with the horizontal pins at the top and the vertical ones at the bottom. The reason why this is important, we know that this pin, which is the enable pin for the relay, basically the pin that sends voltage to activate the relay, is attached to the left hand side. So we should have current coming in from the left, and because there is continuity, if you remember, between pins 85 and 86, this is going to be traveling straight across these 2 pins, and once there is a current, and once these 2 pins are energized, the relay should then close shut across pins 30 and pins 87. That's how this works. Let me see if I can get a close-up of that enable pin on the circuit board. So just here we see a pin, hopefully you can see it. It says REL_AN, as in relay enable. So let's mimic what the actual circuit would have done by supplying the necessary voltages to the relay directly. So one more time, we would have perhaps 12 volts coming across the enable pin to the left. That voltage would travel straight across to pins 86, because remember they are connected. And once these 2 pins are energized, this should then close the relay across pins 30 and pins 87. Now the closing of this relay means that whatever charge is on pin 30 is then going to be able to travel across to pin 87. Is going to be able to travel across to pin 87. Because remember, by default they are not connected, the circuit is open. Yep. Pins 30 and pin 87, the circuit is open by default. Connect the ground lead. I've got 12 volts, well, just over 12 volts on my DC power supply. No click. There's the sound of a spark, but the sound of the relay activating should be quite obvious. So we're gonna replace the relay, test the circuit again and see if that solves the issue. Okay, we've installed a new relay, and hopefully you can remember the orientation of the pins. If you can't, let's have a quick refresher. So remember, to the left we had our enable pin, which was pin 85. Over here we had pin 86 to the right. At the top was pin 87, and at the bottom was pin 30. So pins 30 and 87 form the load side of the circuit, whereas pins 85 and 86 are the control side. And if we were to apply a voltage across pins 85 and 86, that should close the load side of the circuit, and we should hear that audible clicking song of the relay being activated. So let's try that. I've already got my DC power supply on. We've got it at around 12.4 volts, and now just try and get you a better angle. Going to apply the ground to pins 86, and then I'm going to supply power on pins 85, on pin 85 rather, and we should hear the relay activate. That was quite audible, so the relay now works, and that should be the fix for our device. Now notice, even before we open the device, we were able to get some direction about what the problem might be just by observing, or rather in this case, noticing that something was missing. Sometimes diagnosis is just as much about what is missing as it is about what we observe or what is present. Something to keep in mind. So let's fully reassemble this Noco, and I'm quite confident it's going to work. Okay, we've reassembled the Noco. Let's just power it on, see if it still works. Yep, power comes on. Test the torch light. Torch works. Now let's connect the charging cables and test the boost to see if it works, because that's the reason why this device was sent in. Okay, so we turn on the Noco and we activate the boost, and this time we should hear the relay being activated. And we hear that clear audible click of the relay being activated. Let's try that again. Turn the Noco off, back on, activate the boost, and again we hear that relay clicking. And to verify, let's test the voltage across the two charging cables. Our multimeter on volts, and we should get 12 volts. So as you can see, the Noco from the flashing LED, it's still boosting. Black on the black cable and red on the red cable. So I'm going to cover the red cable when I do this, but so you know what's happening. Black probe on the black cable, red probe on the red cable. And as you can see up there on the multimeter, we've got 12.1 volts. So the boost circuit is now working. Let's test again. 12.1 volts. So that's a fix. And that's it. If you have any problems with your Noco, you can send it in to us. You would find the details in the description. We fix all models and versions of Noco chargers. That's it for now.